So today for 4A, we're going to be reviewing negative exponents. Already we've taken care of positives and zero exponents. Now we're going to include negative exponents. Our content objective is students will be able to simplify expressions with exponents that are positive, negative, and zero. Language objective is students will be able to explain in words the process of simplifying exponent problems. Why am I learning this? Well, it's important for real-world problems like representing the size of something very small, such as the diameter of a white blood cell. So right now I'm going to go over a lot of background knowledge, so just put your pens and pencils down and please take a look up at the screen. So first of all, this is what we call our exponential form. So if I ever ask you, write it in an exponential form, this is what I would expect. I would read this as 3 to the 4th power, 3 is your base, 4 is your exponents, and this is what we would call our expanded products, okay? So here are some examples. If I was asked to rewrite and expand as expanded products and evaluate, I would expand it first, then multiply it out so that I can evaluate, okay? Number 2, same thing. Here, our base is a negative 3. I'm going to expand that and then multiply to evaluate. I'm going to get negative 27. So hopefully this looks familiar for you. Here's something that I want to make sure you have down, because I notice some of my students are struggling a little bit here. Special exponent problems. Here, my base is positive or negative. It is positive. Why? Because what's being cubed? Just a 4. If there was parentheses, then it would be a negative 4. So if you're not sure, always ask yourself, what is being raised to the 3rd power? It's just the 4. Okay? So notice the negative stays on the outside. And let me show you another example. Here, again, what's being raised to the 2nd power? Just the 6. And then the negative is on the outside being distributed afterwards, okay? So please know the difference between the two. Do not confuse it for negative 4 to the 2nd power. Okay? So here, again, if I was asked to rewrite as expanded products and then evaluate, here's what I'll get. For number 5, what's being squared? The 5. So you square that, but then you leave the negative on the outside. You would get negative 25. For number 6, here, what's being raised to the 3rd power? A negative 7. So you repeat that 3 times, and that would be negative 343. So here, with positive exponents, we noticed that we are repeatedly multiplying 2's. If you're looking for the pattern, how is it moving from one step down, you're noticing we're dividing by 2 every single time. And the reason why we divide by 2 is because that's our base. So one step further, what is 2 to the 0 power? It's going to be 1. Okay, so again, positive exponent represents multiplying repeatedly. And a number raised to the 0 power will always be 1. So let's take a look here. Now, what about negative exponents? Okay, if I continue this pattern of dividing by 2, notice what happens. Now, 2 to negative 1st is 1/2. 2 to negative 2nd power is 1 over 2 times 2. Okay, divided by 2 again, I'm going to get 1 over 2 times 2 times 2, which is 1 over 8. One step again, I would get 1 over 2 repeated 4 times. So hopefully you see the pattern. Okay. Negative exponents indicate repeated division. So let's take a quick comparison. I'm going to show you. You don't have to write anything down. I just want you to look. If I had 5 squared, what's 5 squared? Everyone? 25. Okay. 5 to negative 2nd would be 1 divided by 5 times 5. Okay, so one side is 25, the other is 1 over 25. So hopefully you already start seeing a pattern. Now if I keep going, here, what's being raised to the 2nd power? The negative 3. So I'm going to repeat that 2 times. But negative 3 to the negative 2nd power would be me dividing by that twice. So I would get 1 over negative 3 times negative 3. So again, hopefully you're starting to develop a pattern in your head right now. So one side, we have 9 with the positive exponent, and on the other side with the negative exponent, we have 1/9. Let's keep going. Here, what's being raised to the 3rd power? 2. So here I put the negative on the outside and put 2 repeated 3 times. But a negative 2 to negative 3rd power, that's 1 over negative 1 over 2 times 2 times 2. So with the positive exponent, I have negative 8, but on the negative exponent, I have a negative 1/8. Are we starting to see a pattern? Yes? Last but not least, here I have 3 halves cubed. So I'm going to repeat that 3 times. But here, for 3 halves to the negative third power, I have 2/3 times 2/3, 2/3 times 2/3 times 2/3. Do we notice a pattern? Okay, awesome. That's what I want to see. Okay, so what I'm going to have you do now is I'm going to have you try some problems on your own. So go ahead and try numbers 1 through 6. Try 1 through 6. So for number 1, what did you get?
I got 8.
8 is correct. For number 2, what did you get?
1/8.
1/8 is correct. For number 3, what did you get?
36.
Perfect. For number 4, what did you get?
1/36.
Good. What did you get for number 5?
81.
81. What did you get for number 6?
1/81.
1/81. So go ahead and double check to make sure that your answers match mine. Okay. Are there any questions? Does anyone need me to go over some of the problems? Okay. So we're moving on. So now I'm going to do one example and I'm going to have you do the next one. For number 7, what's being raised to the third power? 1/2 is being raised to the third power. So I'm going to go ahead and repeat that 3 times. I'm going to evaluate it by multiplying across. My numerator is 1. 2 times 2 times 2 is going to be 8. So my fraction is 1/8. So for number 8, what is 1/2 to the negative third power? Well, it's identical to the first one, except now it's a negative exponent. So I'm going to take the reciprocal. So the reciprocal of 1/8 is basically 8/1, which I would simplify to just 8. So now I want you to try numbers 9 and 10 on your own. So we're going to go over answer. So what did you get for number 9? 4/25 is correct. Please make sure you didn't write 4/10. That's a very common mistake, okay? What did you get for number 10?
I got 25/4.
Correct, 25/4. So now that we know, all we do for negative exponents is we take the reciprocal. Correct. So now what I'm going to have you do is I'm going to have you try numbers 11 through 14 on your own. Okay, so what did you get for number 11?
For number 11, I got 1/9.
1/9 is correct. Thank you. What did you get for number 12?
For number 12, I got 1/8.
Correct. Thank you. So these are the different ways you could have written negative 1/8. All of them will be correct. And what did you get for number 13?
Well, my nice brains didn't get 1/125.
1/125. Thank you. That is correct. And what did you get for number 14?
I got -1/16.
-1/16. That is correct. Thank you. So again, please double check your work to make sure it matches my work on the screen. Does anyone need me to go over any of these answers? Okay, let's move on. So now we're going to explore power to a power. Just a quick review. Please, eyes up on the screen, pencils down. Power to a power, what you do is you take the base and you repeat it, and then you expand, and then you simplify. Okay, so that's how we're going to be working these types of problems. You take your base, you expand them, and then you simplify into an exponential form. Okay, so let's look at this example here. For number 15, according to the order of operations, you need to start what's inside the parentheses first, right? So here, 2 to the negative third power. Well, that negative exponent tells me I need to take the reciprocal. So what would 2 to the negative third look like? Well, it would be 1/2 times 2 times 2 times 2. Okay? But now I'm not done. There's a second power, which is why we call it power to a power. There's also a 2. It's also being squared. So I'm going to go ahead and repeat that group once more to make a total of 2 groups. Okay? So now I'm going to go ahead and simplify. 1 times 1 is 1. And then I have a total of 1, 2, 3, 4, 5, 6, 2. So I have 1/2 to the 6. Okay? Question? No, you do not. Okay, because if it was an entire fraction, if it was a 1/2 being repeated over and over, then yes. But usually when you repeat a 1 times 1 times 1 times 1, no matter how many times you repeat it, it's still just 1. Okay? Other question?
Does it matter where you put the 6?
Does it matter where you put the 6? Yes, thank you for asking that. Because I've noticed a lot of my students have been writing their answers like this. 1 over 2, and they'll put the 6 up here. Okay? What is being raised to the 6th power? The 2, which is why you need to make sure the 2 has the 6th power, okay? That's a very great question. Thank you for asking that. Glad I got to go over that. Okay, so I'm going to go over one more example. For number 16, again, I have to focus on the parentheses first. Can 2 to the negative second be simplified a little bit more? Yes, I want to make it into 1 over 3 times 3. Okay, so I'm going to go ahead and rewrite it with that negative 3 as an exponent. Wait a second. I have yet another negative exponent. So negative exponents tell me to take the reciprocal. So I'm going to have to take the reciprocal again.
Oh, no.
So once I do that, now I have 3 times 3 over 1. I'm going to go ahead and repeat that 3 times. And I'm going to get a total of, let's see, the numerator is going to be 3 to the 6th power. And I'm going to get it over 1, which is why I just write 3 to the 6th power. Okay? Questions? Yes?
So it's not negative anymore once you do that?
Yes, once you take the reciprocal, it's made it into a positive, basically. Great question. Yes, it's no longer negative. Okay? One thing I want to clarify, because I've noticed some of my other students in a different class thought this, negative exponents doesn't tell me my answer is going to be negative. It just tells me I'm going to take the reciprocal. That's all it tells me to do. Okay? So now on that note, I'm going to go ahead and have you try number 17 through 22. Please try numbers 17 through 22. So for number 17, so 5 cubed doesn't have to be simplified, but because it's raised to a negative exponent, I'm going to take the reciprocal of that. And I'm going to go ahead and write it twice. So I'm going to get 1 over 5 to the 6th power. Number 18, on the inside of the parentheses, 4 to the negative 1st power, I'm going to go ahead and simplify that to 1 over 4. But I'm going to have to go ahead and then, since it's raised to the negative 3rd power, I'm going to have to take the reciprocal again and then cube that. So my answer would be 4 cubed. Are there any questions there? Okay. Moving on. So number 19, please write this down. It's 1 over 3 to the 24th power. Number 20 is 1 over 4 to the 21st power. Number 21 is 1 over negative 2 to the 15th power. Notice it's not going to have parentheses around the 2. Okay? Because if I asked you what is 3 being raised to, you would only just say 2. Right? So you have to be very careful about that. Number 22, it's going to be parentheses, negative 5 raised to the 25th power. Number 23 is going to be 3 to the 12th power. And number 24 is 1 over 2 to the 28th power. Any questions?